Hey there, class. Mr. Prosky here. Hope you're having a good day so far. This is Chapter 4. We're doing 4.1, which is Applied Triangle Sum Properties. So this whole chapter is about identifying different types of triangles and proving triangles are congruent using different properties of their angles and sides. And yeah, it's a pretty cool chapter. There will be some proofs in here, but I think these proofs are actually not too bad once you get the hang of them. So not in this section at least, but like in the future. Okay, we have a warm-up. It's here. It says solve for x. We have these angles here. They're in a triangle, but don't really worry about that right now, okay? Go ahead and see if you can figure out what kind of angles these are and see if you can solve them. Go ahead. All right, these are a linear pair. Do linear pairs add up to 180 or are they congruent? They add up to 180, so we're going to add them up to 180. So do 3x plus 9 plus 99 equals 180. All right, go ahead and we got to solve this now. Combine like terms. 9 plus 99 is going to be 108 equals 180. All right, now you get the 3x by itself. We're going to subtract 108 from both sides. Get 3x equals 72. Divide by 3. And we get x equals 24 degrees. Okay, sounds good. Okay, let's get into some definitions here. A triangle is a polygon with 3 sides. How many sides? 3 sides. And 3 angles, I guess, right? It's called a triangle. All right, interior angles, or the angles that are inside the triangle, are what? Inside the triangle. Exterior angles, the angles that form linear pairs. With the interior angle. So here's an exterior angle, okay? Actually up here, this 3x plus 9 is a exterior angle. So if I draw a triangle like this, right? That's a bad triangle. Try to draw a little bit better. So any angle, so look, if I extend the side here, x would be an exterior angle. Y would be an exterior angle. Z would be an Z would be an exterior angle. So basically if you extend one of the sides and the angle that's formed with the outside of the shape, that's going to be a, let me fix this actually, it should go like this. So it goes like, that should be Y, and that should be Z. Okay, so those are exterior angles. They make linear pairs with the inside. This would be a linear pair, right? Okay, a corollary to a theorem is a statement that can be proven easily using the theorem. All right, okay, let's classify different types of triangles by sides. Why don't you guys go ahead and see if you can fill in this list. See how you do. Go ahead and give it a try. All right, a scalene triangle. It means basically these tick marks mean these are congruent. These tick marks and these tick marks right here mean that those sides are congruent. Okay, a scalene triangle, does it have any congruent sides or no? It has 0 congruent sides. How many congruent sides does an isosceles triangle? This is scalene. Say scalene. This is isosceles. Say isosceles. Okay? Isosceles has 2 congruent sides. And this word right here is equilateral. Say equilateral. That's going to have all 3 congruent sides. All right? Sounds good. Okay, let's talk about different triangles by angles. An acute triangle has 3 acute angles. A right triangle has 1 right angle. And a obtuse triangle has 1 obtuse angle. And an equiangular, say equiangular, is going to have 3 congruent angles. One thing I want you to put on the side here is we're going to list angles first. So this should actually go up here when you're listing them, okay? We should actually list triangles by angles first. You should say like acute scalene or acute isosceles, something like that, okay? And then also, we don't really need to say equiangular. We can just say equilateral for triangles. You don't need to say both. That's kind of like equilateral, and it means we're gonna write just this, okay? Okay, so if you don't need to say equiangular or equilateral because they're both are gonna infer that they have to be the same. So you can just write equilateral triangle. Okay? All right, let's do an example here. Let's do example 1. We're classifying the triangle by shape by both its sides and angles. All right, so let's do A. Well, first we're doing angles here. What kind of angles do you see? Well, I see this little red box here. It means that it's going to be a right triangle. So this is going to be a right triangle. All right. And what are the sides? Are any sides congruent or no? They are not. So this is going to be a scalene, a right scalene triangle. Okay? Because it has no congruent sides. I'm going to zoom out here. Why don't you guys go ahead and see if you can do the rest of these. Give them a try. All right, B. It has two congruent sides, and yeah, this should be, and then what are the angles? The angles are all less than 90, so this is going to be an acute isosceles triangle. All right. Now, as for C, this angle right here is pretty wide. That's going to be an obtuse triangle. And how many sides are congruent? Looks like we have two congruent sides right here. So this is going to be an obtuse isosceles. All right, how about D? Any right or obtuse angles? No, so it's going to be an acute. And are any sides congruent or no? It's not, so it's going to be an acute scalene triangle. All right, we have E. Looks like we have all the angles are congruent. And so this is going to be equiangular or just an equilateral. We're just going to put equilateral. Because equilateral and equiangular both mean the same thing. Well, they don't mean the same thing, but they infer that they're both going to have angles and sides congruent. Okay? And then F, do we have any right or obtuse angles? I see a right angle right here, so this is going to be a right, and then we have two sides that are congruent, so this is going to be a right isosceles. Okay, and that's how we label, label different types of triangles, what kind of triangles they are. All right, we have some theorems here. So, triangle sum theorem. This is a pretty important one, and it's pretty easy. The sum of the measures of the interior angles of a triangle is 180 degrees. How many degrees? 180. So basically, all the angles inside the triangle are going to add up to 180 degrees. All right? Corollary to the triangle sum theorem, the acute angles of a right triangle are complementary. Are what? Complementary. So that means they add up to what? They add up to 90 degrees, right? So if this one right here is 90, then these have to be 180 minus 90, which equals 90, right? So these other two have to equal 90. Oops, that's not minus. Oops, okay, well that kind of works. All right? And then the exterior angle theorem. The measure of the exterior angle of a triangle is equal to the sum of the two measures of the two non-adjacent interior angles. So, what does that mean? Okay, so angle 1, I'm gonna do this, okay? This angle, I like to go like this. I like to say angle 1 equals these two added together, okay? So the angle that's, the exterior angle is going to equal the other two angles added together. So it's angle A and angle B. All right? So yeah, that's kind of what I like to draw when I'm doing these problems, is I like to add up, say the exterior angle is going to equal the other two angles that are not touching it. Okay? All right, let's do an example here. So, find the angle measure. So we're looking for the measure of DCB. Okay, so what do we know? Well, this is an exterior angle right here. It forms an angle outside the triangle, right? So this angle is going to equal the other two angles added together. Okay, that's what we're going to do for this problem here. That's kind of what the exterior angle equals. So we're going to do 3x minus 9 equals x plus 73. Why don't you guys go ahead and solve that from here, and then we'll go ahead and figure out DC, and figure out DCB if you can as well. You're going to plug that, what you get for x in back to solve for DCB. Give it a try. All right, we're going to subtract x. So we have 2x minus 9 equals 73. Add 9. 2x equals 82. Divide by 2. X equals 41 degrees. And are we done? No, we are not. We're looking for DCB. So measure of angle DCB equals 3x minus 9. So we're going to plug that 41 in for here. So 3 times 41 minus 9. 3 times 41 is, it's 123 minus 9. So that's going to equal, measure of angle DCB is going to equal 114 degrees. That's the measure of that exterior angle right there, okay? All right, why don't you guys go ahead and we have some Qdoba problems. We have some different types of spiciness here. Why don't you guys pause the video and see what you can do. Some of these are what we just used, some of them are kind of new. And see if you can figure them out, give them a try. All right, so Pico de Gallo, we have a right angle right here, and we have these other two angles, right? So if this is, that's a right angle, then these are gonna add to 90, okay? They're gonna add to 90, that's a shortcut. But if you wanted to, you could just do x plus 34 plus 60 plus 90 equals 180. You could also do that because all the angles inside a triangle add up to 180, or you could just do x plus 34 plus 60 equals 90, right? That's another way you could do it. Either way is totally fine, whatever you're most comfortable with, okay? So if we have x plus 34 plus 60 is going to be 94 equals 90, subtract 94, and we get x equals, it's going to be negative 4 degrees, which is kind of weird, but that's the right answer. If you got that, good job. All right, queso, we have an exterior angle here. This angle is going to equal these two added together right here. Okay, so x plus 127 equals 40 plus 75. Combine like terms, we get x plus 127 equals 115. Subtract 127. You're going to get another negative number here, kind of weird. Negative 12 degrees. All right. Hopefully that wasn't too confusing for you when I turned you loose there. All right, next one, salsa roja. This one's a little weird, okay? This one's a little tricky. So, here's what we're going to need to do, okay? We actually can't solve this as it is right now. We're going to have to do some work here, okay? So here's what we're going to do. We're going to call this angle Y. We're going to call this, what's this angle right here going to be? What's this angle right here going to be? That's going to be 90 degrees, right? Because the other angle is 90 degrees, it makes it a right angle. We're going to call this angle Z, okay? So we have to do some solving, all right? How do we find angle Y? Well, what kind of angles are these right here? Those are going to be a linear pair, so right? So linear pairs add up to 180, so Y is going to equal 180 minus 115, which equals 65 degrees. Okay, so that's 65 degrees, that's Y. All right. Now we got to find Z. This is a little bit trickier here, okay? So for Z, let's see here. Okay, so now we know this is 65 right here, right? So we're going to find angle Z. So Z, well, we have angle Z, we have this angle and this angle. What do all those angles add up to? What do Z, 65, and 90 add up to? Well, they're inside the triangle, so they're all going to add up to 180. So 65 plus 90 equals 180. Combine like terms, we get Z plus 155 equals 190. Subtract 155. We get Z equals, it's going to be 25 degrees. So now we have Y, we have Z, and now we can figure out x plus 164. So we can figure out x plus 164 is going to equal, this is going to equal these two added together, right? So it's going to be x plus 64 equals 90 plus 65 minus 164. Oops, actually no, we're going to combine like terms first. Combine like terms, we get x plus 164 equals 155. Subtract 164. X equals negative 9 degrees. All right, these last two I should have mentioned are pretty hard, so don't worry if you didn't get these ones, okay? All right, let's do the last one here, just for fun. So, we have some angles here. What kind of angles are these right here? What kind of angles are those? Those are vertical angles. Those are going to be, this is also going to be x plus 34. Okay, here's another vertical angle. This is going to be 132. And this angle, we'll call this angle Y. These make a linear pair, so Y is going to equal 180 minus 155, which equals 25 degrees. So this is 25 degrees. So now we can solve for x. Now we have all those angles inside there. We can do x plus 34 plus 132 plus 25 equals 180. Combine like terms. X plus 191 equals 180. Subtract 191. X equals negative 11 degrees. All right, and there we go. Those last two are very tricky. If you didn't get those last two, don't worry. They're not going to be as hard as that on the assessment, but just good for you to kind of see what's happening here, okay? All right, that's all I have for you today. Thanks for watching. Have a great day, and we will talk soon.